So for this next problem, let's come up with a strategy based on how we solved the first problem. So our strategy will be simple, it'll be the exact same that we did before. Our first step is to set our function equal to y. And we're doing that so that in our next step, we can switch x and y. And once we switch them, this is the inversion process, the process of finding the inverse function. Then our third step, we can solve for y, which will now be g inverse of x. And once we find an equation for the inverse function, our last step will just be to check. And you can do this with either the calculator or by plugging in a point. So let's use this strategy, and we'll do our first step. We want to set our equation equal to y. So we have y is minus x minus 2 over x plus 4. And our second step, we're now going to switch x and y. So we have that x is minus y minus 2 over y plus 4. Now this step is the most labor intensive since we need to solve for y and it's in the denominator. So let's multiply each side of the equation by the denominator, this y plus 4. And what we'll notice is that on the right-hand side, the denominator will cancel out with this y plus 4 in the numerator. And we're just going to be left with x times y plus 4 equals minus y minus 2. And now let's distribute here. So we get xy plus 4x is minus y minus 2. And now that we have y out of the parentheses and out of the denominator, we can just put all the y terms on one side of the equation and all the non-y terms, so these two right here, on the other side. So let's just add y to each side. So we get that xy plus y, and we'll subtract 4x on each side. So that's equal to minus 2 minus 4x. And now notice y is on the same side, but we can't combine these since we don't know what x is, so all we can do is factor y out. So we have that y times x plus 1 here. Remember this, when factoring y out here, this has to be a 1 since if you put 0 and redistribute, you would get 0y. Now this will be equal to minus 2 minus 4x. And lastly, let's divide everything by this x plus 1. So we get y is minus 2 minus 4x over x plus 1. And hopefully, if we did everything correctly, this will be equal to our inverse function. So again, there's two ways to check it here. So let me just scroll back over. We can either use the calculator and graph this and numerically confirm it, or we can just pick some random x value, plug it into the original function, and then the inverse function would have the opposite of that point. So let's check with that method since you won't always have a graphing calculator. So we will check this, and let's just pick an easy point. Let's do 0. That's usually a nice point to do. And so plugging in 0 into our original function, you get minus 2 over 4, which would be minus a half. So now going to our inverse function, we're going to do the opposite. We are going to plug in x equals minus 1/2 into here, and hopefully it will be equal to 0, since with inverse functions, the x and y coordinates are going to be switched. So we should end up with the coordinate point in our inverse function of minus 1/2 comma 0 if everything is correct. So let's do that. I'm going to plug that into our inverse function. Let me stick with that yellow color. So we have g inverse of minus 1/2. And in the numerator, we get minus 2 minus 4 times by that minus 1/2 all over minus a half plus 1. And notice in the numerator that we're subtracting a negative, so this just becomes positive. So you get minus 2 plus, and then 4 over 2 is just 2. So we're going to get 0 in the numerator and a half down below. But 0 divided by anything is 0. So we do get the point we wanted. So that means that this does go through the point, minus 1/2 comma 0, which, as you can see, is the switched coordinate point for the x and y values of the point it goes through on a function g of x. So since we got the opposite point, now we can feel very confident that this is in fact the right answer, and that's what we would put into our box here for this Khan Academy exercise.